Hello Gators, this is 8-2 trigonometric ratios, specifically the cosine and sine. And this is the way we spell it right here, cosine and sine. We're going to look at these two new ratios of sine and cosine. Notice I'm only using the first three letters of the word in the abbreviation. The sine is the opposite over the hypotenuse. So here is A, and the opposite is A, and the hypotenuse is C. For the cosine of A, it's the adjacent leg, which is B, divided by the hypotenuse. So these two new trig functions use the hypotenuse, where the tangent did not. Now here's an easy way to remember it. It's called SOHCAHTOA. So stands for sine, opposite over hypotenuse. Ca stands for cosine, adjacent over hypotenuse. Tangent stands for opposite over adjacent. Did you notice that I always say the entire word? I don't say the three letters. You have to say sine, cosine, and tangent. All right, let's go ahead and practice finding the sine of A. The sine of A is equal to, now here the mnemonic helps me. It says it's opposite, and here's A, and I look at the opposite, and that's 3, and then over the hypotenuse, which is 5. The cosine of A, and the mnemonic says cosine is adjacent, so I look for the adjacent leg, which is 4, over the hypotenuse. Let's go ahead and practice this one. Sine of A. Here's A. Sine is opposite over hypotenuse. Here's A. The opposite is 15. The hypotenuse is 17. The cosine of A is the adjacent, and this is the adjacent leg, which is 8, and the hypotenuse is 17. Again, let's look at the sine of A, and the opposite is going to be 24, and the hypotenuse is 25. Cosine of A is the, up here it says adjacent, so that's 7 over 25. The sine of A, here's A, and there's the opposite, 8, and the hypotenuse is 10. Cosine of A, the adjacent is 6 over 10. This is how we get those ratios. Okay, let's take a look at the sine of 30. And the sine of 30 will be the opposite over the hypotenuse. And for this one, it's opposite over hypotenuse, which they're the same. Now let's find the cosine of 30. And the cosine of 30 would be the adjacent, root 3, all over 2. And if here's the adjacent, which is 2 root 3 over 4. And again, that reduces. Now this decimal is 0.5, and this decimal is root 3 divided by 2, which is 0.8660. Now there's a faster way to find sine of 30 and cosine of 30, and that's to use a table or to use a calculator. So here is 30, and here's sine, and if you look at both of those where they meet, that's this one, and that's what we got just a few minutes ago. We got this being 0.5. Now if we look at cosine, and then 30 degrees, we're going to get this one, and that's what we got when we divided by root 3. So these are in our calculator. The calculator will look more like this. If you press the sine button right here, and then press 30, and then press parentheses, there we get our 0.5, and you press cosine, and press 30, and you'll get that decimal we got from the table. It's in our calculator. All right, let's work with 60. Sine of 60, and it says opposite, so we look for the opposite, root 3, and then divide by 2. And we're going to do the same thing over here, opposite, 2 root 3 over 4. We can see these are the same, and that decimal is supposed to be here, sine, here, that decimal is supposed to be equal to, is approximately 0.8660. 60 degrees is adjacent over hypotenuse. Adjacent over hypotenuse, which is exactly equal to 0.5. So here's cosine 0.5. Notice that this was the same thing as cosine of 30 degrees. Let's go back to the previous thing. Cosine of 30 degrees was that. So these two are the same here. And then this one is sine of 30 degrees. So it's interesting that these two have the same answer. All right, let's practice using our calculator. So we're going to press, let me just clear it, sine and then 43. And you notice that here's the sine in 43, that's giving me that same decimal. So tables and calculators give you the same value. And then cosine, press the cosine button, and then press 43. And we're going to get cosine of 43, that's right over here. Yep, we are agreeing with our calculator. Now, knowing these ratios on our calculator will help us solve unknown lengths. So let's go ahead and start. Let's take a look at this. Notice that we need this leg and this leg. We do know the hypotenuse. So we do know a hypotenuse. That means this ratio is not going to be very helpful to us. So let's go ahead and use sine, and we're going to use this angle, 32. And remember that a sine is opposite. Opposite is A. And hypotenuse is 10. And we're going to make this look like a ratio. Now, before we go any further, I want you to know that we have to use trig. We can't use the Pythagorean theorem because we don't have two sides. You have to have two sides before you can find the third. And we can't use 30, 60, 90 or 45, 45, 90. So that's why we're using the trig. I'm going to cross multiply, so this will be 10 sine of 32 is equal to A. Now, remember that this is a decimal, and we're going to let the calculator figure it out. So we're going to press 10, and then we're going to press sine of 32. The calculator knows what the sine of 32 is. It's stored in its calculator, and our answer is 5.3 is approximately A. Now let's go ahead and use cosine. Cosine of 32 is equal to, now here's 32, the cosine is adjacent, which is B, over a hypotenuse, which is 10. Make it look like a proportion, cross multiply. Don't worry about the calculator at this point, just get everything to one side. Remember, this thing the calculator can figure out for us. And so that'll be 10. And then cosine of 32, parentheses, enter. And then this is going to be 8.4, no, 8.5, if I round, will be approximately B. Now this angle will be 58 degrees, and I'm looking, B should be bigger than A, because B is opposite a bigger angle. Okay, find the missing side. Okay, so this is a hypotenuse. So that means I can't use tangent. And this is an adjacent. So I don't want to use this one. I have an adjacent and I have a hypotenuse, so it looks like I want to use cosine. So cosine of 39 is equal to adjacent, which is x, over hypotenuse. Make it look like a proportion, cross multiply. Let the calculator do the work at the very end. And then so we don't need to see the decimal, we just need to let the calculator do it. So this is 7, and press cosine of 39. You really don't have to put the times sign in there. The calculator knows this is multiplication. And so this is going to be 5.4 is approximately x. Let's go on to the next problem. This is an opposite. This is a hypotenuse. And so I don't want to use tangent equals opposite, which is 8, over x. Okay, and I'm going to make it look like a proportion. I'm going to cross multiply x times the sine of 46. Sine of 46 is a decimal. We're not going to worry about that right now. We're going to divide by sine of 46, and we'll let the calculator take care of everything for us later. Okay, so let's go ahead and do that. We're going to press 8, then we're going to press divided by sine of 46. The calculator knows that decimal, and so the answer is, oops, too soon for me, 11.1. Okay, x is approximately 11.1. And 11.1 makes sense because it should be bigger than 8. The hypotenuse should be bigger than the leg. Okay, let's do this again. This is the angle. This is an opposite. This is an adjacent. Notice I did not use hypotenuse at all. So it looks like I'm back to my old friend tangent. So tangent of 27 is equal to opposite over adjacent, which is 10. Make it look like a proportion. Cross multiply. Tangent of 27 is equal to x. Use our calculator. 10 tangent of 27, and we're going to get the answer 5.1. 5.1 is approximately x. Okay, so what we've done so far is we've talked about the three ratios that are going to help us figure out legs. We've talked about the sine, the cosine, and the tangent.